Hello everyone, I'm Irene Viola from the Distributed and Interactive System Laboratory, and my talk today is on quality of experience for immersive communication. Since today we're celebrating the 75th anniversary of the foundation of CWI, I thought of starting by giving you a brief recap of the history of media communication, which will be very brief because it started only 200 years ago in 1826 with the birth of photography. And in fact, by the time CWI was founded in 1946, the first TV broadcasting had not been set up in the Netherlands yet. That will happen 5 years later in 1951. It is weird to think of how all of the technological improvements that have happened in the last 75 years, thinking especially of the fact that we're having this meeting now, sadly, remotely over video conferencing. This wouldn't have even been possible 30 years ago. In fact, in 1993, we had the first video communication over the internet with a much lower resolution and much smaller frame per second rate with respect to what we're used to consider the standard now. So what does the future hold? I believe that the path of communication is to become more and more natural and immersive. So let's see how CWI can help in the research in order to make the future of immersive communication. First of all, let me start by introducing what we mean by communication. We want to establish a connection between entities in order to exchange information. And this, thanks to technological advances, has been set up for remote entities so that we can connect from remote parts of the world as if we are together at the same time. However, this is not natural yet. As anyone having Zoom meetings lately in this year can tell you, talking over a video conferencing is not the same as having a chat over a coffee. How can we bring that naturalness of interaction with non-verbal communication to the remote communication that we're experiencing now? I believe that the path forward is through immersive communication. We want to enable natural experiences and interaction so that we can suspend the disbelief in not being together in the same physical space. We want to connect people in a way that feels natural so that it feels like as if they're sharing the same physical space, even though they're not. We can do that through immersive representation and new technologies such as virtual reality. The trend lately has been focused on creating CGI characters such as avatars in order to interact in a 3D space. However, when we're talking with people, we want to see the other person. We want to be able to communicate. If I'm talking with my family, I want to see them. I don't want to see a CGI puppet of them. How can we ensure this naturalness of communication given all of the technological constraints that we're facing now? That is where the concept of quality of experience comes into play. We need to put a human-centered perspective on the communication system that we're building now, and have it in such a way that the quality is determined by the reaction of the users and not through the system. We move from the traditional concept of quality of service, which was completely set up by the system that we were enabling and was not considering how the end user was perceiving the content that was transmitted over the system. Now we move towards a quality of experience in which the human is at the center of it all. So what we want to do here at CWI is to measure and model the quality of experience in order to understand and to optimize immersive communication, to build the communication of the future. This problem doesn't come without its challenges. We're talking about a huge amount of data, but the sheer amount of data is not the only problem. We're not talking about moving from a HD video to a 4K video, in which, surely enough, we're creating more data, but the structure is the same. The content is as we were used to. In this case, we're talking about a higher complexity of data, multi-dimensional and irregularly structured data. You can see there in the slides that I'm presenting you, the close-up of a light field image in which the same content, in this case, the close-up of the eye of a person, is seen from multiple perspectives. So this allows us to change the point of view so that we can have a more natural interaction with the 3D space instead of having a 2D image. This is not the only representation available. We can think of volumetric media such as meshes or point cloud, or omnidirectional images such as 360-degree video. The multiple representation are not just available through different technology. Thinking about the 360-degree video, we have different ways of mapping a sphere onto a planar surface in order to perform our computations. And each of those transformations comes with its perks and its disadvantages. We need to be able to understand this data in order to make it in such a way that we can properly optimize, so that we can remove all of the redundancies that exist in this data without compromising the quality. The complexity does not only lay on the data side. The users also have more freedom. We're moving from a passive paradigm of traditional video in which we cannot really interact with the content beside moving forward or backward in the timeline. Now we can decide actively where we're looking at and how we're exploring the space. We add more degrees of freedom in how the users behave, which means that every user experience will be different and personalized. We don't have a one-size-fits-all strategy. We need to adapt our models to the user. Our research focuses on three main pillars. We want to quantify user experience, to model user experience, and to optimize user experience in real time. In terms of quantifying user experience, we need to enable a user-centric perspective. What does it mean? It means that we need to analyze how users behave in our immersive system in order to better understand, in order to collect data that can help us optimize this system. We can do this in three main ways. First of all, we can identify regions of interest in the content that they're looking at so that we know what are the salient parts of the content that we want to send. This is called creating saliency maps of the data at hand. We also want to analyze how users explore the space. As we said, they can change actively their position and their point of view. So analyzing how they explore the space can help us understand where to better allocate bitrate, for example, depending on the part of the content that is most seen by everyone. And then we want to understand how people engage with each other and with the content at hand. So we want to study the interaction in this virtual space. In terms of quantifying user experience, some work has been done, not too much. In our site, we've conducted a large-scale interlab test in order to understand user behavior and quality perception. What we did was analyzing 360-degree video under a plethora of influencing factors, such as the methodology, the quality methodology under use, the display technology, the sequence duration. And this was all a basis for a contribution to standard submitted to the ITU recommendation body and formed the basis of the ITU recommendation P919, which is now in force. In terms of modeling user experience, what we want to do is to predict the user behavior, starting from the data that we have measured in the step before. We want to go one step forward and be able to predict from the position that the user is setting now, how they will move forward. We want to understand what are the influencing factors in visual perception so that we can understand what are the parts that they like more and what parts are salient and key for the quality of experience. We want to understand and infer how users will react to a given content and being able to quantify that numerically so that we can have an idea of how our system is performing. We want to model the visual quality and the enjoyment that the users have with respect to the system that they're exploring. In terms of that, we've created, for example, some objective quality metrics that are able to predict what will be the visual quality of a given point cloud content. And in particular, we proposed a reduced reference metric, which doesn't need to rely on the full pristine data in order to compute a measure of distortion. Since we're talking about volumetric data, we couldn't just rely on image distortion, which is what has been used, for example, in traditional media, but we also had to include a measure of distortion in geometry, for example, to be able to take into account the 3D perception of the data. All of this is key in order to optimize the user experience and in order to build the system of the future that is able to create immersive communication between entities. In particular, we want to create systems that are able to adapt to the user and that are removing data in a smarter way. We don't want to simply destroy the data that was existing before in order to just compress it. We want to remove what was redundant and to keep what was important for the user. We can do that by improving the delivery, by predicting the user behavior and their perception. And we can also improve our compression solution by using saliency and quality information. We've done that by proposing a low complexity tiling algorithm for real-time point cloud adaptive streaming. And to do so, we measure first how users interact in 6 degrees of freedom virtual reality environments. And then we build our model and we test it on a variety of bitrate scenarios. And we show that our user adaptive solution lead to up to 57% bitrate saving with respect to a non-adaptive solution. We want to go also one step further. All of the models that I've been talking so far have been generally for a quality of experience, but an entertainment case will be very different from a healthcare-based case for immersive communication. We need to take into consideration what is our end goal in order to build models that take into account all of the factors that influence the perception of our content. In particular, considering that AI is more and more part of our daily life and our system, we need to take into account these steps in order to model and to create algorithms that take into account not only the end perception of the user, but also the processing step that will happen, for example, in intermediate steps between our acquisition and our delivery of the content. If we optimize our compression solution to remove features that are perceptually irrelevant for users, we might destroy an AI algorithm that relies on these features in order to compute its metrics. We want to create a synergy between quality of experience and AI so that we can take into account the use case, especially considering that in some cases, it's not an end user that will see the final content, but it will be a machine. We think, for example, of automated driving, in which we can capture immersive data that will be fed then to a machine that can understand automatically what is the composition of the scene. We need to take all of this into account in order to build a quality of experience model that can really make artificial intelligence human-centered. So to conclude my talk, I do believe that this is the future of communication, and I believe that here in CWI we are taking active steps in order to make that happen. So I hope that in 2046, for the 100th celebration of CWI, we will be able to celebrate in person instead of this video conferencing, but maybe we can connect with remote people from all over the world and we can really feel as if we are in the same room. So with this, I conclude. Thank you so much. And if you have any question, I'll be happy to answer.